In this video, we're going to talk about something which is a little bit strange sounding at first, but it turns out we've actually been doing it all year long. It's this thing called compositions of functions. The idea is we take one function and plug it into the next function. If you remember, the idea of a function, as I have diagrammed by this conveyor belt over here, is that you take an input, plug it into some rule, which could be an equation where you plug numbers in. It could be a table where you just look up results, but some rule where you're going to be able to take the input and turn it into an output. That's a function. The basic function is you take x, you plug it into f, and out comes your y. We would call that f of x. That's the y value. A composition of functions is the same idea, except it's in two stages. We take some input, plug it into a function, and then we take the result of that first function and plug it directly into the next function. That's what we call a composition of functions. It has a new symbol, which you've possibly never seen before. Right now I have it drawn. It's not drawn quite right here. It looks like a degree symbol there. It's really not. Really, the circle really belongs lower. We read this as f of g of x. F of g of x. What that means is we're going to take the result of g of x and plug it into f. Take the result of the inside function, which in this case I have written as g of x, and plug it into f. We'll see some examples that make it very concrete and easy to understand. Here are a few functions. On their face, they have nothing to do with each other. They're just three different functions. Now we're going to do some things to combine them, like f of g of 2. Means we're going to take 2, we're going to plug that into g, and we can do the math there. G of 2 is 2 squared plus 2 minus 1, which is 5. And then I'm going to take that 5 and plug it into f. That's the key here, is we take the 5, whatever we get out of the innermost function, and we plug it in to the next function. And so f of 5 is simply 5 plus 3, which is 8. Which means our final answer, and I do want you, again, just like with the operations from the previous video, I want you to make sure you rewrite the question again. F of g of 2 is equal to 8. An important thing to note is that if we're plugging in just a number, our result should be just a number. If we were plugging in a variable or a variable expression, then that should come with our answer also. Okay, we'll do one more together. H of f of 5. Remember, it meant that you start with the inner function. By the way, this could also be written as h of f of negative 5. Two ways of writing the same thing. So we need to know what is f of negative 5. That looks like f plus 5. That's not what I wrote. F of negative 5. So f of negative 5 would mean taking a negative 5 and plugging it into f, which is negative 2. And then we take the result of that and plug it into h. So we're going to take h of negative 2, which you're going to see is going to cause a little bit of a problem. That would mean the square root of negative 2, which technically is the square root of 2 times I. Generally speaking, we're not going to worry about imaginary numbers here, but in this case, the result is imaginary, so we would write it that way. Slightly more complicated looking, though not any more complicated really in action, is when you're asked to simplify a composition where you're plugging in an x value. And not evaluating a specific number. Scroll down too far. see my functions. So f of g of x. In this case, I have no number to plug in to g, but what I need to do is take whatever g is and plug it into f. So that would make it f of x squared plus x minus 1, because that's what g of x is. And so I'm going to take that x squared plus x minus 1 and plug it in for x in that spot there, which means I still need to add 3 to it. And so there's very little work to do on this one. All I have to do is combine the -1 and the 3. And that's really it for this problem. F of g of x is equal to x squared plus x plus 2. It is going to be slightly more complicated the other way, because in this case, I'm taking f of x and plugging it into g, which means I'm looking for g of, well, f of x is x plus 3. So I'm going to need to take that x plus 3 and plug it in to x squared plus x minus 1. And this does get hard to get used to. You'll get there, but it takes a little bit of getting used to this idea that x becomes x plus 3. It's a weird idea. But what this notation means, g of f of x, means we take whatever f of x is and we plug it in for the input into g. And so what's going to happen is we're going to get a sort of like a shortcut, a rule for doing that all in one step. That's the idea of evaluating these compositions. Make a shortcut so that instead of having to do a number into f and then take that result and plug it into g, if we just write the function out once, then we can plug numbers directly into this shortcut. So this does require foiling. X squared plus 6x plus 9. Nothing to distribute here. But then I do need to combine like terms. 6x and x can combine. And 9 and 3 minus 1 is 11. So that is g of f of x. And notice how g of f of x and f of g of x are very different. They're both quadratics, but they're different quadratics. And this last one here is actually quite easy. I just wanted to show it to you because I want you to make sure you realize you can plug a function into itself. It just means do f of x. So whatever number you're taking, you're going to plug into f, and then take the result of that and plug it into f again. Totally happens all the time. So remember, f of x is x plus 3. So we're taking f of x plus 3, which is taking x plus 3 and plugging it in for that input. So that's x plus 3 again. So that's x plus 6. And that is f of